Hello everyone, today we're going to be going over a system design course today, and today we're focusing on Cypher queries and graph queries. Now, to be able to give a breakdown overall over how we approach Cypher query language and graph queries, and mainly we are focusing in SQL. Is that graph databases bring to life the overall intricate map of relationships that are inherently complex and interconnected. So we already know that graphs, databases can focus on relationships, and we also know that they have vertices and edges. Vertices being the entities and edges being the relationships. And so the language used to query graph databases is overall crucial to understanding how we extract the data itself. And it is where Cypher enters the stage, which Cypher is a declarative language focusing on the what for data extraction. And it's widely tailored for Neo4j's property graphs. So it's a language that allows us to define patterns in our data graphically and retrieve information with precision and elegance. Cypher's simplicity in syntax and its power in execution enable us to ask intricate questions about our graph data. Take, for instance, the search for individuals who have migrated from one country to another. Cypher handles this type of data and data extraction with ease, allowing us to traverse the graph with patterns that match our query conditions, much like a flashlight to follow a trail to the dark. But what if our data lies within the familiar yet rigid structure of a relational database? What about structured data in a database? Relational. Overall, can we still emulate the agility of graph queries in SQL? The answer is a conditional yes. We can still traverse data in the database like a graph. But not as efficient. Because queries tend to take a longer time to be able to write out, and they tend to be more complex, as well as understanding how we apply recursion relationships between data extraction. However, this doesn't take away SQL's power and universality, but it does highlight the elegance of Cypher in the context of graph databases. The choice between SQL and Cypher is not merely on syntax, but also aligning with the most natural expression of data and also application and preference at the same time. So it will all differ. So let's just move out. And feel free to take a screenshot, and let's head over to our concept example. And now to go over a concept example, let's consider tracing migration patterns. So let's consider a scenario where we wish to uncover migration patterns within our social network. Using Cypher, we can effortlessly de-alienate and extract paths of individuals who move from the US and Europe. Here in Cypher, namely, we're able to make it very easy and very seamless to be able to extract the name type along with the contents of it and be able to go through in a list type order. However, in SQL, we have to apply a lot of recursion. This is pretty syntax heavy to be able to go into until we finally get to what we need to specifically get to. We're able to define clear relationships in Cypher. While SQL, on the other hand, applies recursion. Since given the fact that both Cypher and SQL lead us to the same destination, there is a bit of a different series of syntaxes that have to be applied whenever we have to take different paths. Overall, Cypher glides through the graph data model with extreme amounts of ease compared to SQL. Since SQL largely has to focus on a declarative, needs to approach this with a declarative query. Cypher is able to mitigate that by providing more efficient syntax. And now to go over our first practice problem, let's focus on analyzing social media influence. So let's apply the concept of from what we have learned about ciphering and to this practical scenario. So we need to imagine that we need to analyze the influence spread in social media networks. And our task is to identify users who have migrated their content creation from one platform to another. So focusing on content migration. From one platform to another. And the entities we need to consider as well is that we first need to identify the pattern. Along with execution of the query. And what we have done really in this Cypher script is that we're matching users based on the content that they have created on platform A, and then also collect the followers within platforms, followers from said platform as well. Then we also need to match the content within platform B, and then overall collect the followers accordingly. And then we execute a query where we always start with match, as indicated over here. Indicated here, where we also we're able to identify and extract what specifically content and the followers as well from both platforms, and we return the collection of followers as well. So this is our first example or practice problem that we would show, focusing on the application of the ciphering. And now let's go over a second practice problem. So in our second practice problem, we are tracking an ecosystem of business networks and exchanges. So we need to imagine a networked ecosystem where businesses interlink through partnerships, mergers, and collaborations. So we're focusing on business partnerships, mergers, and collaborations. And our goal is to track the evolution of these connections over time. So step one, and we have also already cleared out the Cypher syntax as well. Step one, we need to map the initial state. Step two, you also need to follow the evolution. Of the business networks as well. And three, we need to understand the dynamics. When we have done so, we're able to label out specifically how the Cypher would actually go. And remember, every time that we're using Cypher to make a query request, we're always using match and then also returning specifically what we are doing. As we can see, it's a very strong declarative approach between matching between the business relationship and other businesses. So we get the business relationship right here. And then we can also see the other indicators such as timestamps as well, such as where we can have a start date, end date, and return as well. We match and then return as likewise. And so yes, this was the application of ciphering queries and graph queries in overall SQL in its present applications. Thank you again for taking time to watch this. If you found this video helpful, be sure and feel free to like and subscribe. And if you have any other questions as well, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.